Hello, Axel. Hello, Solus. How are you guys?
Hi,
Good.
Tarek. Good.
Hello, Tarek.
Good to see you.
To see you too.
So, guys, we are here to discuss about this new solution that we have at Dassault Systèmes called MBSE Electrical, or model-based wire engineering, end-to-end MBSE Electrical. So, guys, so you know that this is brand new for Dassault Systèmes, combining MBSE and electrical both together. By the way, we say electrical, but it could be as well hydraulic, means tubing, piping, and HVAC. So basically, this solution, which is brand new, is coming, I would say, since we acquired Magic. And thanks to this acquisition, we are able today to combine our end-to-end electrical and MBSE solution to promote and to at least to promote the processes and to have, I would say, a real end-to-end digital thread. So, having said that, Axel and Solus, so we should perhaps introduce ourselves. Please, Axel, first.
Thank you, Tarek. Sorry. Yes, so I'm 10 years plus part of Dassault Systèmes, and mainly my role were to support the electrical solution technical engagement, and more recently as well, including fluidics. So I'm leading the technical team, and I'm very glad to introduce today this new solution with you, Tarek, and Solus to our community of experts.
Hello, very nice to meet you again. I'm SERY CHAИB Pavalkis. I'm 20 years with Magic, now Dassault Systèmes, and my background was in R&D, building this product as an analyst, product owner, now solution leading MBSE transformation here in the United States. And I'm very happy to see how best of system engineering can connect with the best of electrical in the interactive integration as an integrated data set, not only the tools.
Thank you, Solus. Thank you, Axel. So on my side, so I'm SERY CHAIB. I'm the CATIA CTO. I'm leading CATIA for overall CATIA now for almost 3 years. Before that, I was leading CATIA Electrical and System, and I'm 23 years now at Dassault Systèmes, and I'm coming from aerospace industry where I was engineer, and I started my career with CATIA V3 and then V4. So basically a long story with CATIA and CATIA Electrical.
Wow, impressive. Okay, so let's go.
So basically, as we started, Axel and Solus, and that this is something that we were expecting since a long time, and customer was pushing us for that. They were looking, I would say, strong collaboration between MBSE and electrical, and the majority of benefit, I would say, underlined and highlighted here, which is early validation. We know that earliest we validate and earliest we are true in our execution, and better we will deliver at the end. We would like as well to have a collaborative platform, meaning something where we could collaborate between mechanical, electrical, hydraulic engineers. We would like to have as well a full digital thread, EWIS compatible. Why? Because we can trace the information from specification till, I would say, manufacturing or even in flight. Early design validation and optimization. This is something as well customers were looking for. We would like to have a full integration between the functional definition and the electrical definition. And we would like to have something which is full 3D or model-based oriented. So basically, those are in fact the benefit that the customer were looking for today. So Axel, could you tell us more about those benefits?
Yes,
perhaps in the next slides, perhaps?
Yeah, good point. So yes, right. All those benefits and value we propose are based on the paradigm or the concept of the platform. So it's a full digital continuity between the components all along the process and the development phases of the program of an aircraft. Not only aircraft, but any product, from requirement, functions, system in the logical layer and physical view. This process, you'll see, it's strongly architecture-driven. We take the benefit of the architecture visible and shared for all the systems to anticipate the electrical requirement, the electrical constraints. So it's good for the EWIS, taking into consideration the constraints for EWIS development as early as possible. When we integrate it during the architecture definition, we detect and we anticipate the maximum of constraints and challenges better than during the detailed design. And you'll see for the electrical new capabilities as well, it's based on the data creation automation and the assistance for the electrical definition through a content of engineering rules stored into the platform. So this makes a concurrent engineering approach where we have one single source of truth for all the designers, starting from the architect to the electrical designer, the 3D model responsible till the manufacturing. So it's really model-based driven.
Thank you, Axel. Thank you very much. It has been very clear. And by the way, let's move to the next slides, and then we'll discuss a bit more about the processes. So this process is a process that we will for sure discuss and comment. But I would like to add to that at the end of this presentation, we'll show a brief, I would say, video describing a bit in action how this is articulated. So basically, the first part of it, which is the system architecture. Okay. Solius, could you tell us a bit more about this, I would say, system architecture topic, about this, I would say, Cameo stuff, and what is the value out of it?
Yes, as a system architects, the main role is to remove the silos, actually to investigate, what the designers do, in the 3D and the electrical, and connect those dots. So with the actual modeling of system architecture, model-based system engineering, we raise the level of the abstraction from the independent design decisions to actually integrated system level decisions, not only with the electrical, but also 3D, right? What we have here in the 3D wire harness. And actually we connect those dots through system architecture. And would be that logical architecture, which is like based on functions, what system does, and aggregated functions as a logical components interacting through interfaces. That becomes as an input to the design. And actually it also requires impact from the design decisions, because we never start from empty. In most cases, we start from something what already exists, and we meet in the middle. That's what system engineers do, meet in the middle.
I agree. Thank you, Solius. And okay, how do we plug, in fact, this, I would say system architecture, and how those architects, in fact, work with, let's say, the designer or early stage designer? So is there another, I would say, value out of it?
It's bigger value, actually, because we can actually interact with the design decisions. For example, electrical components has the size, right? And they are electrified components, so we can get them early into architecture to understand what we have to allocate based on those components, in size and weight and, power consumption. Those things we can get early into architecture in order to do right allocations for the system decomposition. Also, we know from the system, what would be the logical interfaces. So those interfaces would impact the physical interfaces, right?
I see. I guess we can see it in the next slides. Potentially, this is what you are describing, right, Solius?
Yeah, exactly. So those 3D zones, the equipment, what would be the allowed place, size of the equipment, electrified equipment. So we get them into overall architecture. Then from library, we can model components and connect those components. And based on the places of components. So that's another important information, because if you place them, in a wing or tail or, front panel, right, that would be the different type of wires needed and the different size of wires, right? Needed length of wires, right? So that's pretty much what we want to achieve. And we need all those pieces. We need the system architecture, we need connections, we need the size of the equipment, and we need the 3D and for 3D wire harness, and we connect those together.
So if I may summarize what you're saying, Solius, if I understand right, is you are telling me that today we can interconnect the system architect with, let's say, the 3D designer or the 3D system architect designer somehow in a very early stage. Okay, we can interact, in fact, those guys together that we are not discussing before. And this is the first layer of the way we integrate system architecture and electrical both together, right?
You are right, to put them on the same picture.
On the same picture means in a very early stage, I could have even more than that, by the way, Solius. Even the mechanical designer could start collaborating together, right?
Yes.
Okay. So, Axel,